Friends, before entering the problems based on even and odd numbers, let us have a look at some basic properties regarding even and odd numbers. So first I will go to addition and subtraction. At least I will take two numbers, because for addition or subtraction or multiplication at least we need two numbers. So first I will take addition and subtraction, we will see the results, and then we will go to multiplication, right? Suppose if you take an even number plus or minus an even number. For minus, I am taking this one as great value and this one as least value, so that we can get positive integers like natural numbers. So even plus or minus will always give even. For example, if you take even plus 8 plus 4 is equal to 12. 12 is an even number. 8 is an even number, 4 is an even number, 12 is an even number. Suppose if you take minus some other numbers, 8 minus 4 will give 4. So 8, 4, 4, all three are 4 is an even number. Similarly, if you take odd numbers, odd plus or minus odd number will also give even number. Let us take two numbers like 3 plus 7 will give 10. 10 is an even number. 3 is an odd number, 7 is an odd number, 10 is an even number. Similarly, if you take 7 minus 3, that is equal to 4. So if you go for mixing of odd and even, if you take even plus or minus odd, will always give odd. Okay, suppose this is even, I am taking 8 plus 5 is equal to 13. 13 is an odd number. Okay, if you take 8 minus 5, that will give 3. 3 is also an odd number. Similarly, odd plus or minus even will also give odd number. The same thing will get reversed. Okay, so even plus or minus even will give even number, odd plus or minus odd will give even number, even plus or minus odd or odd plus or minus even will also give odd values as the answer. This is the first basic verified rule that we have checked with the natural numbers. Let us go into multiplication now. If you go into multiplication, even into even will always give even. Just like 4 into 6 will give 24. So 4 is an even number, 6 is an even number, 24 is an even number. Now odd into odd will always give odd. Suppose 3 into 7, that is equal to 21. Suppose if you make mix of both, even into odd, that is 8 into 5, that is also even. Even into odd also will make even, 14. Now these are the odd into even also will give even number. So even into even will give even number. So we have taken some examples. 4 is even, 6 is even, 4 into 6, 24 is also even. So odd into odd also will give odd values. So 3 is odd, 7 is odd, 3 into 7, 21, which is also odd. Now even into odd, mix of both, if you multiply even number and an odd number, then also you will get even number, because even is more dominating in multiplication. Even is more dominating. You continuously multiply any number of odd numbers, you will get odd result. But in the middle, if you mix even one even number, the whole product will become even number. So even is more dominating in multiplication. Now similarly, my dear friends, if you take the power is also kind of multiplication, multiplying the same number up to these many number of times. Suppose if you take even to the power of even number or odd number, that means whatever may be the number, you are multiplying even number into even number into even number, like that. So obviously the answer will be even number. Similarly, if you take odd and if you write the power even number of times, even number and odd number, that means basically you are multiplying odd number into odd number into odd number. So you will get odd. It's a kind of multiplication, not necessary everybody will understand, but still we have written all the results, important results and rules, whatever you think, that is even into even is equal to even, odd into odd is equal to odd, odd into even is equal to even. So even to the power of even or odd, anything. Suppose if you take some examples, for this I am taking, so 2 power 2, even I am taking 2 power 2 is equal to 4. If you take 2 power 3, that is odd, that will give 8. Both are even numbers, right? So if you take odd number, I am taking 3 to the power of 2, that is equal to 9, that is an odd number. Okay, 3 to the power of 3, that is equal to 27, that is also an odd number. So obviously we have proved and we checked all the rules. Now we shall go into an important doubt. Many students ask, sir, is 0 an even number or an odd number? There are so many doubts regarding this point. Is 0 is an even number? We should consider 0 as an even number or odd number. Let us go into that topic and let us clarify our doubt. So my dear friends, here to clarify the doubt whether 0 is a even number or odd number. So many people say 0 is an even number, we should not consider 0 as an even number or odd number. It is neither positive nor negative. It is correct that 0 is neither negative nor positive, but what is its status in the integer family or in the whole number family? Because when 0 is added only, we get whole numbers, right? So I have taken the verified formula. For time being, I am testing what happens if 0 is an odd integer to this formula, to this already proved formula. So for the time being, I am taking, let 0 be an odd integer. मान लीजिए 0 is an odd number, right? So we already know odd number plus simply addition I am taking. Minus also you can take, minus number also you can take, or minus operation also you can take. That doesn't matter. So odd plus odd number, we have to give even number, that we know already. So 0 को मैंने odd मान लिया, so I have taken 0 as an odd number. And 3 is already an odd number, so 0 plus 3, what is the value of 0 plus 3? That is 3. And here 3 is not an even number. 3 is not an even number, 3 is an odd number, so the rule got violated. The rule got violated, okay. So if we take, if I take 0 as an odd number, so odd number plus odd number will give even number, that we know already. So 0 I have taken odd number because I assumed like that. And 3 is already an odd number, so I added them according to the rule. We are getting an answer called 3, which is not an even number. Now coming to the second point, even plus or minus even should be an even number. So instead of taking minus symbol, I have taken minus number, nothing else here. So even number I have taken minus 2, plus even number again I have taken 2, that means I am getting 0. Why I am taking same number? So that I will get 0 in the equation. That is my intention, that's why I am taking the numbers like this. So even number minus 2 and again even number 2. So minus 2 plus 2 will give 0, and 0 is not an even number because here assumption, against the assumption, basic assumption, because we assumed in the beginning that 0 is an odd number, but 0 here is coming in the place of even number. So here this rule also got violated because in the beginning only we assumed 0 as an odd number. Now coming to the third point, even plus odd should give odd number. So even I have taken 2 and odd number I have taken 0 because first only I assumed 0 as an odd number. So 2 plus 0 will give 2, and 2 is not an odd number, and 2 is an even number. 2 is even number. So what happened, my dear friends, when I am assuming 0 as an odd number, none of the 3 rules that were verified, they are not being checked or re-verified here. So all are being violated, all the rules are being violated when I am assuming 0 as a odd integer. Now let us see what happens if I assume 0 as a even integer, right? Now friends, here I have taken 0 as, I assumed 0, let 0 be an even number. So in this case I am assuming 0 as an even number. Now again I have written the rules, odd plus odd should give even number. These are already verified. Odd plus odd is equal to even plus even should give even, and even plus odd should give odd. So here I have written the equations in such a way so that I will get 0 on this side or that side. So I will not write the answers for now. Let us check whether we are being verified or not. So okay, so I have wiped out the answers. We will get the answers now and we will check whether it is correct or not. So odd number is 3. Here again I have taken odd number. You understood, I think I am writing these equations in such a way so that I should get 0 in the LHS part or RHS part. Then only we can check the validity of 0, right? So here odd numbers I have taken, odd number plus odd number should give even number, that we know already. So I have taken 3 and minus 3. So 3 plus minus 3 should give 0, will give 0. And 0 here it is an even number, correct, because we assumed 0 as an even number, so it is coming as true. Okay, next one, even plus or minus we should give even number. Even plus even number should be given as even number. Here even number I have taken as minus 2 and here even number I have taken as plus 2, and again minus 2 plus 2 will give 0, and again 0 is an even number because we assumed 0 as an even number in the beginning itself. So second rule also got checked, verified properly. Okay, now third one, even plus odd should give odd number. So in the place of even 0 I have taken because 0 I assumed assumed as even in the beginning itself. So odd number I have taken 3. So 0 plus 3 will give 3. Yes, 3 is also odd number. No need to say anything, right? So all the 3 rules, odd plus odd will give even, even plus even we should give even, or even plus odd should give odd. All the 3 rules are verified if I take 0 as an even number. So if anybody asks you whether 0 is a odd number or even number, you should not use the word actually that is called number. You should say 0 is neither positive nor negative. 0 is neither positive nor negative. 0 is a even integer. So I think it is better not to use the word called number, because when you say, in general, when you say number, people will assume it as a natural number. So 0 does not come in the natural number family, 0 come in whole number family. When 0 is added, natural numbers will be extended to whole numbers. So whenever you talk about 0, better to about the even status or odd status of 0. So better not to use the word number. You should say 0 is neither positive nor negative. 0 is an even integer, like that you should say. So that is the actual value, because we verified when we assumed 0 as an odd number, so all the rules got violated. But when we assumed 0 as an even number, all the rules are being verified properly. The right answers are coming, right? So we should say 0 is neither positive nor negative. 0 is an even integer. Friends, let us have a look at this question. If x is the product, of 4 consecutive natural numbers, consecutive means successive, 4 consecutive natural numbers, and what is n? N is also defined here. N is equal to 1 plus x. Then which of the following statements is true? So what are the statements that are given? N is odd, n is prime, n is a perfect square, and the options are 1 and 3 are correct, 1 and 2 are correct, only 1 is correct and only 3 is correct. First, let me explain you the meaning of the question. He is telling, suppose the first natural numbers he told. What kind of natural numbers? Consecutive natural numbers, successive natural numbers. मान लीजिए the natural number that we are taking, the first natural number that we are taking is some a. Okay. Now consecutive, that means a plus 1, a plus 2 and a plus 3. मान लीजिए these are the 4 consecutive natural numbers. Okay. So now I am multiplying them. A into a plus 1 into a plus 2 into a plus 3. He is telling this product should be named as x. So what is x? X is product of 4 consecutive natural numbers, and then he defined n. What is n? N is equal to 1 plus x. That means whatever this product is there, n is equal to whatever the product we get, we have to add 1 to it. You have to add 1 to it. Now he is telling this n plus x, this 1 plus x, whatever n is equal to 1 plus x, this is odd or prime or only prime, only odd, like that options he has given. Friends, to solve this question is purely based on properties of natural numbers. If you know a property, a very easy property, I think in previous videos also we have discussed this property. If you know this property, we can answer this question on the spot. You need not calculate anything, you need not even take the examples also, if you know this property properly, right? What is that property? First we will know. Friends, since the question is about 4 consecutive natural numbers, I am taking 1, 2, 3, 4. 1, 2, 3, 4. He is telling product x, that means 1 into 3, 1 into 2 into 3 into 4. And then we have to add 1 to it. What is 1 into 4 consecutive natural numbers plus 1? That is what he is telling. Multiply 4 consecutive natural numbers and add 1 to it. Am I right or not? Then what will be the result? 1 into 2 into 2 into 3, 6, 6 into 4 is equal to 24, 24 plus 1 is equal to 25. The result is 25. One more example we will take. 2 into 3 into 4 into 5 plus 1. 2 3s are 6, 6 4s are 24, 24 5s are 120. 120 plus 1 is equal to 121. Like that, so many examples we can take. 3 into 4 into 5 into 6. Okay. So 3 4s are 12, 5 6 are 30, 30 12s are 360, 360 plus 1 is equal to 361. Like this, so many we will get. Clearly we can see this number is not only a perfect square, but it is also a odd number. This is not only a perfect square, this is also an odd number. 25 is a perfect square. 5 square is equal to 25 and 25 is an odd number. 121 is a perfect square. 11 square is equal to 121 and 121 is an odd number. 361 is a perfect square. 19 square is equal to 361 and 361 is an odd number. So this is one of the most beautiful property that is being repeatedly asked in the examinations. So you take any 4 consecutive natural numbers and product them, multiply them. You take any 4 consecutive natural numbers, multiply them, you get a product and add 1 to that product. You will get a perfect square. Not only it is a perfect square, it is also an odd number. So here statement 1 is correct, here statement 3 is also correct. So option A will be the correct answer. Just like that, we can read the question and we can put the answer there if you know this property well. Okay. So let us have a look at this question. Every prime number of the form 3k plus 1, he is taking a prime number which is in the form of 3k plus 1, can be represented in the form of 6n plus 1, where k and n are integers. Okay, integers. When k is odd, k is even, k can be both odd and even, and no such form is possible. This is a very simple question. This is a very simple question. We can solve this question with only one very small point. Even number should be written in the form of, can be written in the form of 2n. If any number which is in the form of 2n, we will call it as an even number. Odd number, it should be in the form of 2n plus or minus 1. So where n is integers, right? Where n are integers. So sometimes you will get positive integers, sometimes you will get negative integers, etc. etc. Okay. So if n is taken as natural numbers, well and good it is. Okay, you will get all natural numbers only. Okay, now even should be in the form of 2n and odd should be in the form of 2n plus 1. This is the only point that we should know to solve this question. So let us take 3k plus 1 case, and what happens if k is a even number and what happens if k is a odd number. Can we write it in the form of 6n plus 1 or not? We will check it now. Okay. Now when k is odd, number, k is odd. First I am taking even number. Let us take even number. Even number means it should be in the form of 2n. Okay. Even number means it should be in the form of 2n. So 3k plus 1. So in the place of k I am putting 2n. 3 into 2n plus 1. That means it is 6n plus 1. Yes, I am able to write it in the form of 6n plus 1. Now when k is odd, I am also taking the case of odd. When k is odd, that means when it is in the form of 2n plus or minus 1. 2n plus or minus 1. So 3 into 2n plus or minus 1 plus 1. Okay. So 6n plus or minus 3 plus 1. Okay. So 6n plus 4, in case sometimes it can be 6n plus 4 or 6n minus 3 if I take minus 3 plus 1, 6n minus 2. So in one form I am getting 6n plus 4, in other form I am getting 6n minus 2. So in any case I am not getting a form called 6n plus 1, right? So if k is taken as an odd number, in that odd number also if I take 2n plus 1 or minus 1, both the forms I have taken. So if you take it as plus, 2n plus 1 if you take, I am getting 6n plus 4 form. If I am taking 2n minus 1 form, then I am taking 6n minus 2. So this proves that n should only be even. If n is even, for every, you take any prime number and in the place of k, if you put only even number, then only we can write that prime number in the form of 6n plus 1. For odd values, the respective form is not coming. So k must be odd only. K must be only odd. Option A is correct.